Welcome to the DIY3DTech.com channel.
Welcome to this edition of DIY3DTech.com. In this episode, we're going to follow up the last, where we're actually going to run some code on the laser cutter. Wanted to go through a couple things, but first, one little point from the last video, that when we did the Inkscape presentation, when you go to create the G-code, before you hit apply, you have to make sure all the paths are selected, so you need to highlight and select it. I'll probably do another video doing some more updates, but I just wanted to get that out there, or else it'll just basically give you a semi-empty file with only some preprocessor code in it. So anyways, I wanted to get that out there because I noticed that when I went to do another one, because I actually changed this to a circle because it's doing a few strange things. One of the things it's doing, and I can't figure out why, is it goes to its starting point and then stops and waits like 3 or 4 minutes and then does its thing. So I'm not quite sure why that's the case. So I have to figure that one out. But what I've done here is just talk about a little bit of the setup. So I've got my Probotix CNC machine here. I've had it for 4 or 5 years. It's been a good little machine. Probably one of the first generations of the CNCs, home CNCs. In the past video, you've seen where I've updated it to Garble. So Garble's driving the parallel port controllers for this. And what I've done is I've made a mount here to attach to the porter cable spindle holder to attach this reworked laser mount, and I've got my 2-watt laser here. I've already focused it. I have this wheel set up for the Z-axis. I just raise and lower the Z-axis, to home it and then also position it. So that's ready to go. It is energized on, and basically the relay control, when I went over another video, has it turned off for right now, so an M04 command has been issued. I'll activate the control electronics in a minute, and then we'll get to cutting this piece of paper. But I got an 80-pound bond stock piece of paper here. Also, what I've done is, to protect the table a little bit, I've taken a 12 by 12 inch tile, turned it upside down, and using that sort of as my bed. It's also real important to have this bed leveled. I didn't do that good of a job on it. Again, I'm just trying to a little short on time, but want to see how all this works. Because my plan is not so much to leave it like this, but I'm also building another dedicated laser CNC machine out of Maker Rail. The red laser you see down here is just the aiming laser for the spindle to be used as a CNC machine. I've just kind of got it in there for reference because I've been kind of running it around, seeing how the G-code works. So what I'm going to do is actually, because it does take a little bit, is I'm going to stop the video, then start another video, then so I can time lapse it as it goes through, so you don't have to go through the paces. Because to cut this circle, it takes about 17 minutes. Now, it shouldn't take 17 minutes. I don't know why it's stopping. I still need to figure that part out. If you know why, maybe message me and you can figure it out before I do. But it's stopping at the first part of the G3 code, where it tells it to go to the first move. I don't see why it should stop it. I don't know if it's in Garble or the G-code. So I'm going to have to look at some of my other G-code that I've run off Cut2D and see where that differs from this G-code and do a diff on it and see. But anyways, let's cut something. Now, remember, it's going to look kind of funny. I'm using one of my cheaper cameras. I don't want to damage the CCDs on my more expensive cameras with this. I will be wearing safety glasses. I do have red safety glasses, which are important. The one thing, note, you can probably see the red laser through these because these are red glasses, so red blocks blue and blue blocks red. So, make sure you get the right glasses for the laser that you have. And then also, make sure the room is clear of pets, because they have eyes too and they don't have glasses on, because there is reflective light off this, and especially because this is white paper, even the light off of it, even though it's not a direct reflection, will be rather intense. So you should not look at this. So warning right there. All right, I'm going to stop, and then I'm going to restart everything, and then we're going to do some laser cutting. Oops, sorry about that. So we're back. So you just saw it, cut it out. Actually, I cut this at about 50 millimeters per minute, and I think that was actually about the right speed. I might have been able to go a little bit faster, but I did have to push it out of the paper a little bit. What wasn't much, it just, but I don't think I could have gone much faster. Maybe 70. I don't think I could have cut this at 100. So again, it did work. Now, still having some problems in the Gcode that's coming out of the Inkscape plugin. So again, for some reason, I kind of showed part of it, so I showed it start, and then that was real time as it moved here. Then I'm going to fast forward the cutting of this, because that's kind of like watching paint dry, but you can kind of get the idea of what it's doing. And then, you know, this is obviously the result here of, but really, for all in all of what this can do, it's pretty amazing, because I've got about $70 tied up in the, which is interesting. This isn't even warm after running for about 5 minutes. They do have the fan on it. This is about $70. Now you can buy them fully assembled. I've seen off eBay. The cheapest price is about $150. So this housing was $17 out of China. The laser diode was another $35 out of Bulgaria. And so actually it might have been a little bit less than 70. I was thinking I had around 70 in it. So actually pretty cheap, because the unit comes with the fan, the heatsink, and the lenses down below. Now I've not bothered putting my hand down here. I've got the power cut to it. And make sure you have the power cut to it, because it's no different than this spindle here. Make sure the power is cut. So very affordable. I 3D printed these parts, so a couple bucks. Where I have the $70 is we don't see off cameras. I've got $11 or $12 in a laser driver. So yeah, about $70 total for the hardware out of China, and about 3 weeks to get all the stuff, because it comes on a slow boat from China. So, but for under $100, I've made this, adaptation, and that's one of the things I wanted to see with this. Now, I'm building its own carriage, and that's probably going to cost about $300 to build an all-aluminum version of sort of what you see here, customized to the laser. However, if you just have a CNC machine and you want to add a laser to cut, this is the way to go for under $100. Now, again, as I pointed out in the Inkscape tutorial, you can drive this Z-axis. Now, I didn't do it here. However, and that's one of the things I do want to experiment with, is how thick of a material I can actually cut with this. So this is about 3/1000 of an inch thick paper at 80-pound bond, because I've measured it, a little short of 3/1000 actually. So how thick I can actually go, it could be interesting, because now like for example, balsa wood. I think balsa wood will actually cut easier than this paper because number one, it's white, and it's in a way denser than balsa wood. So balsa wood I think will cut faster and easier, and I think I can go with a thicker piece, 450, but I could even slow this down to 25 and probably cut double the thickness. But also, again, as I mentioned before in the last video, what I'm excited about is being able to continually move the Z-axis down and to do repetitive cuts. So with the 2-watt laser, I could probably cut some fairly heavier material. Now, it's going to take longer, obviously, a lot longer than if I had a higher power laser. However, you could still do it, again, as a hobbyist to be very interesting. Also, what I'm going to be interested in is I'm going to try to get some of this as black and see how fast it cuts. Now, without this table, I've tried cutting some hobby foam and stuff, and it just, like a hot knife through butter. So again, pretty excited about how this turned out for the amount of money and everything else. So again, though, safety first. I can't say that enough. Make sure you're safe with it. This is dangerous. Again, keep pets and kids out of the room while you're doing it. Make sure you have the proper goggles. Research it. I think the blue laser actually works the best. The blue light is more energetic than the red light, just because of where it sits on the spectrum. Red, green, blue. So, but actually, if you look at the frequencies, the reds are in the higher, like 900 or so nanometers, or probably 700 to 900 nanometer range, wavelength-wise. Where the blue is in the 4 to 5s. So again, the lower the number, the more energetic the light. So, anyways, hope you enjoyed this video. I'm going to be doing, I think, a lot more on this. I do have to do some traveling for work, so it'll be a little bit, but I do plan on, when I get time, doing a lot more. I plan on improving this bracket. Once I do, I'll put it up on Thingiverse for other people that are interested in using it, as well as this one. Again, some minor modifications with this. One of the things I'm also thinking about, you probably noticed in the other video, the fumes, that takes away from it because the laser light is actually attenuated by the fumes. So I'm going to build a small little air assist or vacuum assist, if you will, probably working off this regular vacuum setup here to suck the smoke in and run it through an air filter, because it does get smoky. This wasn't bad. If you're going to do plastics, make sure you have very good ventilation. Don't do vinyls or anything that could be caustic. Again, research it on the internet. You can create a lot of dangerous fumes with this that could harm yourself and family. So again, just be forewarned. But anyways, like it down below if it helped you out, and also subscribe to the channel. Cheers.